MathNation. This next video has us discovering distributive property together. How can you write out 2 times 5 using addition? So as usual, we're going to do a little bit of thinking to get to the distributive property instead of just throwing it out there and figuring it out later, right? We're going to figure it out as we go. If we want to write 2 times 5 using addition, we know that's 5 added together twice, right? 5 plus 5 is 10, 2 times 5 is 10, same thing. We can write it out using addition. What about 4 times b? How could we write it using addition? Well, if we wanted to write it using addition, we'd say b plus b, how many times? 4 plus b plus b. This applies to any terms that are being multiplied. So any terms that are being multiplied could be written out in the same way. What if we wanted to write out 3 times a plus n using addition? Could we? Yeah, we absolutely could. So in that case, we would write a plus n plus a plus n plus a plus n, right? We've got all 3 there. 3 times we're multiplying or adding a plus n here. How many a's are added together in repeated addition? So we see a occurs here 3 times, right? 1, 2, 3. What about the n's? How many times do we see the n's? Also 1, 2, 3. So the a's are added together 3 times. The n's are added together 3 times as well. So what we've done here is we've just discovered that 3 times a plus n is the same as 3 a's, or 3 times a, plus 3 times n. Because if we write it out like this, and we regroup these, we're going to see that 3 a's and 3 n's is what we get. Okay? Now, let's move right along. We want to do a little bit more expanding. Let's expand 2 times 8x plus 3y. So this is just 8x plus 3y added together how many times? Well, added together twice. 8x plus 3y plus 8x plus 3y is the same as 2 times 8x plus 3y. So we're going to rearrange it a little bit, just like we talked about before. We're going to put together all of our x's and all of our y's. So we can write this as 8x plus 8x plus 3y plus 3y, right? So we just did a little bit of switching around and regrouping. Doesn't change the value of the equation at all. How many 8x's do we have here? Well, we have 2 of them, right? So this means that 2 8x's plus 2 3y's is going to be the same as what we started with, which was 2 times 8x plus 3y. Now, what's 2 times 8? 16. What's 2 times 3? 6. So we actually have 16x plus 6y. So the term distributive, we talked about distributive property. It comes from the word distribute, which means to spread out. If we're going to distribute candy bars to everyone at snack time, I bet you know what I mean, right? We're going to throw out all those candy bars and we're going to give them to as many students as we can. We're going to distribute it. Just like the snack machine or the soda machine distributor comes and distributes snacks or sodas to your school or to the hospital or wherever you find a drink or a snack machine. So in this case, we just distributed multiplication across addition. So we did it kind of the long way, but what the distributive property states is that a number on the outside of a parentheses can be multiplied through all of the terms on the inside. So just like above, what we did when we had the 2 on the outside is we multiplied it by each of these terms. So it became 2 times 8x plus 3 times 3y plus 2 times 3y. Tongue-tied today, huh? So let's practice that a little bit. We want to simplify 4 times 11r minus 3t. Instead of expanding it out and regrouping, we can use what we know about distributive property. is that each of the numbers on the outside is multiplied by all of the terms on the inside. So sometimes what I like to do is draw a little hump to show myself that I'm going to multiply it by everything in there. That way I know that I need to multiply 4 by both of the terms in my binomial. That's what this is called, a binomial. So 4 times 11 is 44, so we have 44r. 4 times negative 3t is going to give us negative 12t, or that's the same as minus 3t, right? So 4 times 3 is 12, and that's the same thing as subtracting 12t. So we've got distributive property here without even having to expand it. As long as we understand the idea of expanding, like we did here in our example above, we can use what we found here to keep a rule of thumb for distributive property, which is just to multiply everything on the outside by everything on the inside of parentheses, and that makes distributive property pretty easy, right? Good job.